Okay, so with all the snow days, obviously it's pushed everything back. Last Thursday we were going to review for a quiz. Last Friday we were going to take a quiz. So we're going to review today. You're going to take your quiz tomorrow. I think you guys are all fine with these skills, so I'm not too worried about you. So on your quiz tomorrow, it will have numerical expressions, which is 7, the product of 7 and 3 added to 10. So you'd write down 7 times 3 plus 10, where it gives it to you in words, and then you have to translate it to a numerical expression. After we go over page 538 and 539, which was your homework last Wednesday, you will have most of the class period to work on the IXL skills that you just wrote in your planner. Okay, so numerical expressions, O.3 that's up there on the board is like one operation. So it would say like the sum of 6 and 2. What numerical expression goes with the sum of 6 and 2? Jack?
6 plus 2 in parentheses.
And that's it, just 6 plus 2, because it's only one operation. That's O.3. O.4 is where there's 2 operations. So it would say the sum of 6 and 2 multiplied by 3. What would that one look like? The sum of 6 and 2 multiplied by 3. Paxton?
6 plus 2 in parentheses times 3.
Good job. 6 plus 2 in parentheses and then times 3. Okay, so that's what those skills are for, the O skills, numerical expressions. So if those are things you feel like, hey, I need a little more practice on, when you have time in a few minutes, I suggest go to those skills. What do you think OOO stands for? Order of operation problems. Their skills 05, 06, 07 are all order of operation problems. 05 is the easier one. 06 is a little bit harder. 07 is a little bit harder. Okay, those go in order from easiest to hardest. So if you feel like you still need more order of operation problems, those are the ones I suggest you do. The last 3, T2, T3, and T4 are all on coordinate planes. One of them, it shows you a point on a graph, and it'll either ask you for the x coordinate or the y coordinate, not the ordered pair, which is both. Okay, so you'll have to know the difference of which one's the x coordinate and which one's the y coordinate. How do we know that? How do we know which one is the x and which one is the y? Callan? So in an ordered pair, here, let me pull up whiteboard real quick. Ignore all that for a second. And that. In an ordered pair, so first, who can give me an example of an ordered pair? Someone give me a, Cam?
5, 9.
5, 9. Okay, in the ordered pair 5, 9, which one is the x coordinate? Lena?
5.
Why?
Because X is on the bottom, and you always think X in the alphabet comes before Y.
Yeah, because in an ordered pair, x always comes before y, just like in the alphabet. So the first number is always the x coordinate. The second number is always the y coordinate. What about from a table? If I have a horizontal table and I say that this is the number of people and the number, and we'll just say the other one is dollars, and then there's numbers 4, 5, 6, 10, 20, 30. First, where can I get ordered pairs from a table? Where can I get ordered pairs from a table? Jack?
Top number is the X coordinate.
Okay, the top number is the x coordinate. You are correct. So that's x, so that means these would be y. So who can give me one ordered pair from that table? Briley?
4, 10.
4, 10 would be one ordered pair. What is the x label for this table? What is the x label? Paxton?
Number of people.
Number of people, yeah, okay. What do I do if the table is this way? A vertical table. Which one's the x and which one's the y? Kanan?
The Y is on the right and the X is on the left.
Yeah, so it's just like an ordered pair. I think these ones are easier because if the same information was here, okay, those two tables are exactly the same. It's just the first one is a horizontal table, the second one is a vertical. I think these ones are easier to pull the ordered pairs from because really all you do is put the parentheses around it, add the comma in the middle, and you have your ordered pairs. Okay, so that's skills T2, T3, T4. One of them is pulling ordered pairs from tables like we just talked about. One of them is giving the x or the y coordinate of an ordered pair. And the other one I think is plotting points or giving the ordered pair if the points are already on the graph. Okay? And I feel pretty confident that you guys are all going to do just fine even if we have the quiz tomorrow. Okay? First thing we're going to do before we go over page 538, the weekly worksheet for this week has a lot of review on it. So I want you to pull it out. We're going to do one together right now because it goes with what we're taking a quiz on tomorrow. Look at the example. What kind of problem is that, Jalen? It is a numerical expression. Chase? Yeah, it's an order of operations problem, but she's correct. It is a numerical expression. What could I write down the side of my paper to help me remember the order of operations, Briley? Yeah. So let's just down the side write P, E, M. Do I want to put the D under the M? Nope, I want to put it next to it. Why? Because it's from left to right. Multiplication and division go in the same step. We just work from left to right. What I've noticed is you guys do really good following the order of operations until the exponents and parentheses are gone. And then we get a little crazy. So let's work through this example 1 together. Emmett, what am I going to do first? Okay, why am I going to do 5 plus 3 first? Okay, what is 5 plus 3? 8. So I'm going to put an 8 here. What do I do with everything else, Emmett? Drop it down. Briley, what am I going to do next? Exponents, because I got my parentheses, so now I'm going to my exponents. 6 squared. Slow down. Cam, what is 6 squared telling me to do? 6 times 6. Is 6 squared 12? No. What is 6 squared equal to, Lena? 36. So I'm going to write 36 divided by 4 times 8 minus 7. Here's where we start going crazy typically. We want to do 8 minus 7 is 1 because that's a really easy math problem. Do I do that next? No. In my order of operations, what am I looking for? Stella, what am I looking for? In my order of operations, what does this MD stand for? It's not multiply and then divide. It's multiply and divide left to right. From left to right. Okay, that's why we put them in the same step there when we write out PEMDAS. So we start on the left. What comes first, a division problem or a multiplication problem? Division in this one. So what is 36 divided by 4? 9. Good job. Times 8. I'm going to drop down my minus 7. Jalen, what am I going to do next? Am I going to multiply or subtract? I'm going to multiply. Good job. Jalen, what's 9 times 8? 72. I'm running out of space here. 72 minus 7. Livy? 65. What should my work look like? An upside down triangle. I'm going to point out this number 3. What's weird about it? It has decimals. Do we know how to subtract, add, and multiply with decimals? Yes. Okay, that one's going to be a little bit trickier because of that, but I threw it in just to show you we know how to do those. Livy, will you pull the door shut for me real quick? Thank you. Okay. On this weekly worksheet, I want you to scroll down It's all a lot of decimal review at the top. At the bottom, I want you to circle number 8. On Wednesday, because our quiz is tomorrow, so I don't want to waste any of your time tomorrow. On Wednesday, I'm going to help you get started on number 8. Okay, so I highly suggest you start on your weekly worksheet tonight because you don't have any other math homework. On Wednesday, we are going to go over how to set this problem up. A lot of you did just fine on the last one, but I want to make sure we're all on the right track there. Okay, so number 8, we're going to start to set up together when? Wednesday. Okay, then flip it over to the back. The back is a little bit different than normal. It says the last 10 you will have to go to IXL.com to complete. You will go to skill U5 and complete 10 of the questions in the boxes below. You will write down the original problem and your work. Notice, what are the first 2 boxes? Examples. We are going to do those 2 examples, when do you think? On Wednesday. Okay, so will you be able to do these back problems before Wednesday? No. Okay? They're not hard problems. Once I teach you how to do them on Wednesday, you guys will have Chromebooks Wednesday. You will have plenty of time to get those 10 problems done. Okay, it's just you've never seen it, so I'm going to show you. I'll probably do about 5. You guys will just copy down 2 of them, and with those 5 examples, you guys will be good to go to get those 10 problems done. Okay? So set your weekly worksheet aside. Besides that, I highly suggest, because you don't have math homework tonight, because your quiz is tomorrow. Do you think you'll have homework tomorrow? No. My suggestion is get all but number 8 and those last 10 done Monday and Tuesday. So then you don't have to worry about it the rest of the week. Okay, that's my suggestion. Okay, now get your book open to page 538. We're going to go over homework from last Wednesday. 538, 539. I have all of the answers up here. But there's some of them I want to talk about. Erase some. Can't erase it all. Okay, you're going to check your own answers in just a minute. I want everybody to go and look at problem number 23 first. I want to talk about 23, 24, and 25. Besides that, I'm going to have you check and correct your own. And if you need me, just raise your hand and I can come help. But I want to discuss 23, 24, and 25. So number 23 says, there's lots of information here. Glenn swam 2 laps every morning for 7 days. In addition to the laps he swam each morning, he swam 3 laps with his friends on Tuesday and Thursday. Write the expression that shows the number of laps he swam during the week. Then evaluate the expression to find the total number of laps he swam. Now, I'm going to pick on Paxton just because I see him right here in front of me. He has 2 different math problems. When it says write an expression, you have to try and combine everything that it's wanting you to do into one big problem. Okay, so let's start at the beginning. Naomi, read me the first sentence again on 23. Okay, if he swam 2 laps every morning for 7 days, Avery, how can I show that if I'm trying to figure out the total number of laps? Okay, so what math problem can I use to figure that out? 2 laps a day for 7 days. Yeah, multiply what? 2 times 7. So I'm going to start with 2 times 7. The next sentence says, in addition to. Callan, what do you think I need to put in my numerical expression if the next sentence starts with in addition to? A plus sign. Can anybody think of something else I might want to go ahead and throw in here? Jack? We're not there yet. Before that. Cam? parentheses, because these two have to stay together, because I know that I have to take 2 times 7. Okay, Jack, read me the rest of the information that's important. Okay, why 3 times 2? Because it didn't say anywhere in there that there were 2 days. Yeah, so you had to kind of make an inference there that Tuesday and Thursday is 2 more days. Why did I put parentheses around those ones? Jack? Yeah, to keep them together. Who thinks they have the correct answer when you evaluated that? Briley, what'd you get? 20 was correct. Okay, so that should have been 20 laps. That one was pretty tricky, so I wanted to make sure we all had it. Does it make sense?
Yes.
Okay. I saw in a lot of papers where you did the right math out to the side, you just didn't have the expression. Remember, part of this chapter is being able to write an expression if we're given a word problem. 24 was kind of confusing. It said, before leaving the grocery store, Kenny wrote the y coordinate first and the x coordinate second when telling his sister where to meet him. To his surprise, she was at the right location. If his sister did not make an error, where did the siblings meet? So this says if he was supposed to tell her to go to 6-3, where would she have actually gone?
3-6.
So he told her 6-3, but he meant 3-6. So if he told her 6-3 and she went to 3-6, would she be at the correct spot? No. So why are the grocery store and the fountain, if you look at the ordered pairs I wrote up there on 24, the grocery store is at 1-1, the fountain was at 4-4. Why, even if he told it to her wrong, would she end up at the right place, Nolan?
Because if you flip the numbers, they would have been the same spot.
Yeah.
They're both the same.
Yeah, sometimes like on quizzes and tests, the ones that even if you're unsure how to do these, if you're making a common error of flipping them, you get it correct if the coordinates are the same. So the grocery store was at 1-1, the fountain was at 4-4. Why do you think I have fountain boxed in as the answer? Why do you think I have fountain boxed in as the answer? They both would be the correct spot if they flipped it. But why is the fountain the correct answer, Jack?
Because he left the grocery store.
He's at the grocery store now going somewhere else. Okay, so if you put grocery store, that means you have a good idea of what it was wanting here to know that if I flip them, it's still the same point. But do you see why the answer is actually the fountain and not the grocery store? Okay. Number 25 says write the coordinates for the playground, the fountain, and the bank. Okay, I have those up here, 3, 6, 4, 4, and that's a 5, 5, 2. The next part asked us to describe the pattern for each coordinate. So this is something, when I was watching, a lot of people skipped that part. They wrote the coordinates, but they skipped the pattern. So over here, and on yours, you need to write an X pattern, and we're going to have a Y pattern. So first, let's focus on the X's. Reese, what 3 numbers up there are my X coordinates? 3, 4, 5. Reese, what pattern do you notice? What's happening? Yeah, they're adding 1. So the X is increasing by 1. And I like how she said add 1. This is kind of above where we're at right now. In the future grades, you will write that as X plus 1, showing that the X value is increasing by 1 for each point. Now let's look at the Y coordinate. Chase, what numbers am I focusing on now if I'm looking at my Y coordinates? The 6? The 6, the 4, and the 2. Chase, what's happening to my Y coordinates? If it's 6, 4, 2.
They're moving up 8.
6, 4, 2.
Oh, wait, they're going down 2.
They're going down 2. Yeah, they are decreasing by 2. Who thinks they know the coordinate notation, which is this fancy looking thing? Who thinks they know the coordinate notation for my y's? Paxton?
Y minus 2.
Yeah, y minus 2. Again, that's not a 5th grade thing, but it's not hard once you know what that stuff means. Okay, besides those ones, those are the only ones I wanted to make sure we had a conversation about. For the rest of them, I want you to check your own. If you miss it, what do you think I would like you to do? Try and fix it. If you need your help, what should you do? Raise your hand and I will come help you. If you check them all and you're good to go, or if you miss one, you get it fixed very quickly, the rest of the hour, I want you to work through some of the IXL skills over on the side. You do not have to get to a certain SMART score on any of them. If you feel like you need more practice on numerical expressions, focus on the next two numerical expressions. If you feel you need more order of operations, focus there. If you feel like you're pretty confident, just do a few in each skill just to make sure you're on the right track. At any time, if you need help, what should you do? Just ask for help. Okay, questions? Paxton. No, I don't want you working on your weekly worksheet right now. I want you reviewing for your test. Yes. Any other questions? Just get all of the ones out of the cart. Okay. Okay, so you guys can go ahead and start working. If you need me, raise your hand, and I will come to you.